Alright, welcome back. This is our snow day video on rational expressions, and this video is for students third period and fourth period students that are out in the afternoon on March 5th. Now, second period students, you guys have already done this in class, but third and fourth period, you guys have to complete this video and these 3 homework problems. Okay, you'll get credit for the notes and for the homework itself. But if we don't have school Friday, okay, so if you're watching this video, just remember, if we don't have school Friday, I will post an additional video. So 1 video for each day that we're out. But okay, so today's lesson is rational expressions. And you guys have already seen this. Remember, we've studied rational expressions in the past. Rational expressions are polynomials. Polynomials divided by polynomials. Now you may remember, if I write, let's say x squared minus, or let's do plus 3x minus 40 over x minus 5. On top you see what? A trinomial. On bottom you see a binomial. Remember, we're dividing. This is what? A rational expression. Why is this a rational expression? Because there's a variable in the denominator. Question, is x squared minus or plus 7x minus 3 a rational expression? Yes. More specifically, we call this a trinomial because there is no variable in the denominator. However, if I write x squared plus 7x minus 3 over 7z, because there is a variable in the denominator, the most specific thing we can say is rational expressions. So we are looking at rational expressions today, polynomials divided by polynomials, and here we have a trinomial divided by binomial. Now, reminding you that you've already simplified these in the past. So I guess specifically, what are we doing today with rational expressions? We are simplifying. Okay, so we're not quite done simplifying things in this class. Simplify means to add, subtract, multiply, and divide. And today we're going to focus primarily on just multiplication. So you see multiplication, multiplication, multiplication. We are multiplying big fractions by big fractions. Or do you see a ratio of polynomials, a binomial divided by binomial, multiplied by a binomial divided by binomial. Now, the fact that because you've factored in class, this lesson is going to be very, very simple if you know how to factor quickly. Now, looking at what we've already done with rational expressions, just a quick brief. When dividing by a binomial, remember when there's a binomial in the denominator, we use either long division or synthetic division. So in the past, you did this. X squared plus 3x minus 40 divided by x minus 5, just a quick review, and we asked the question, what times x gives x squared? What times the front gives the front? You answered x. X times x gives x squared. We take the x and multiply by both. X times x is x squared. X times negative 5 is negative 5x, and we subtract both. Now, we don't like to subtract, we like to add, so we change the signs and add. X squared plus negative x squared cancels. 3x plus 5x is 8x. Bring down the negative 40 and start the process over again. So we ask what times x gives 8x? That is 8. We take the 8 and multiply by both. 8 times x is 8x. And 8 times negative 5 is negative 40. We change our signs and we add. The 8x and the negative 8x cancel. Negative 40 plus 40 also cancels, giving a remainder of 0. Now, our answer on the board we have an answer of x plus 8. Now, you see that the process of long division, synthetic division, whether we use long division, or we use synthetic division, the process takes a while. There's several steps. How many of you out there would like to do this in far less time? I mean, we can save ourselves so much time not having to do long division if we know how to factor. Let me show you. This problem becomes very, very easy if you know how to factor. So let me write it over here. If I write x squared plus 3x minus 40 over x minus 5, it would be very nice if we could just simply cancel something. So my question is, first, does the x cancel with the x? Does the x cancel with the x? And hopefully you say from what we've talked about in class, absolutely not. Why do these x's not cancel? Question, does the 5 cancel with the 40, leaving an 8? Absolutely not. This is completely wrong. Why do these not cancel? Okay, so we have x squared plus 3x minus 40 over x minus 5. Why does the x not cancel with the x? Or why does the 5 not cancel with the 40? Remember, addition. Addition locks up our terms, or it locks up the products to the left and to the right. So we see that x squared and 3x are locked up because of the addition. Also, we have addition or subtraction here, which locks up the products to the left and to the right. Do we have addition in the denominator? Yes. Does it lock up everything in the denominator? Yes. Everything is locked up because of the addition. Is the x free to cancel? No. Is the 5 free to cancel? Absolutely not. Why not? Because addition locks up both terms to the left and to the right. Let's compare this with the problem. If I write 40x squared over 5x. In this problem, do you see any addition? No. You see all multiplication. There is no addition. You have multiplication between your 40 and your x squared. You have multiplication between your 5 and your x. Multiplication either side. It's all multiplication, so you're free to cancel. You can cancel your 5 with your 40, leaving what? 8. And you can cancel x with x squared, leaving x. And we get an answer of 8x. When can you cancel in this class? You can cancel when there is multiplication. But you are not allowed to cancel when there's addition, because addition is like jail bars. It locks everything up to the left and right. So looking at this problem, x squared plus 3x minus 40 divided by x minus 5, how are we going to create a situation in which we can cancel? Well, we have to create products. We can arrive at this answer much more quickly by factoring. Remember, factoring means what? Well, it's the reverse of simplify, we know this, but factoring means to create products or to create multiplication. All right? Create products or to create multiplication. And if we create multiplication, we can then cancel. Watch how easy this problem becomes. So we read from the right. Can we factor the top? Yes. We read from the right to the left. Reading. Okay, so what we did in class. Reading. We're looking at what? The factors of 40 that subtract to make 3. What factors of 40 subtract to make 3? We write the factors of 40 are 1 times 40, 2 times 20, 3 does not work, 4 times 10, 5 times 8, 6 does not work, 7 does not work. We get 8 times 5, or the repeat. So we look. What factors of 40 subtract to make 3? Hopefully you say that's 5 and 8. And so we write two binomial, or we set up two binomial factors. We say x times x gives the x squared. And what factors subtract to make a 3? What factors of 40 subtract to make 3? That's 5 and 8. So we put the 5 and the 8. Does it matter where we put the 5 and the 8? No. What matters is where you put your signs. Remember, if we're subtracting, the signs are different. Okay, then we look to our center. Since our center is positive, remember the larger of these two numbers matches the center. So my question is, which one gets the positive, which one gets the negative? Hopefully you say, since the center is positive, the larger number 8 gets the positive, and the 5 gets the negative. And now we have over the binomial x minus 5. Now my question here, does the x cancel with the x? Absolutely not, because the addition does what? The addition locks up every term left and right. Question, does the 5 cancel independently with the 5? No, because addition locks things up. But I want you to notice something. After you've factored, what have you created? You have created products to the left. Look to the left of the binomial. Do you see multiplication to the left of the binomial and multiplication between? Do you see multiplication either side of this binomial? Hopefully you say yes. Do you see multiplication either side of this binomial? Yes. We're looking at the unit. The whole binomial is a unit. Do you see multiplication either side of the x minus 5? Yes. So the unit x minus 5 and the unit x minus 5 have multiplication either side of them. Notice, the 5 and the x have multiplication either side of them, so they're free to cancel. Since the unit x minus 5 has multiplication either side of it, we can cancel x minus 5 with x minus 5. And what is our final answer? Our final answer is what? X plus 8. Do you see that x plus 8 matches our answer here? And what process takes far less time? Well, hopefully you say the factoring is much, much quicker than using long division. So you see that we have other methods for simplifying rational expressions. Remember that rational expressions are polynomials divided by polynomials. Okay, so 3 examples that are going to be identical to your 3 homework problems. So let's look. Notice, what operation is between? Notice that we have multiplication between. When there's multiplication, we can cancel. All right, so let's look. First example, really quick. Try to make this brief so you guys aren't sitting here watching for forever, but you guys can start on your homework. Very quick, we're looking at x, well, let's do v minus 7 over 2v. This is just like problem number 1. 2v plus 12 multiplied by 10v plus 60 over 3v minus 21. Now, my first question is, does the v in the denominator cancel with the v in the numerator? Hopefully you say at this point, absolutely not. Why does it not cancel? Because the addition does what? The addition locks up the products to the left and to the right. So the v on top does not cancel with the v in the denominator. Why? Because we have addition locking up our terms. Are the v's here free to cancel? No. Is the 3 free to cancel with the 60? No. The addition does what? Locks up all your terms. The addition locks up all your terms. So do you see that everything is locked up and unable to cancel? So how do we undo this or unlock it? We have to create what? We have to create a situation of multiplication. We have to factor to create multiplication. So what we're going to do, we're going to look at v minus 7 over 2v plus 12 multiplied by 10v plus 60 over 3v minus 21. And remember, in this class, we factor everything down to what? Everything down to first degree. I told you guys, once you get to first degree, you don't have to factor anymore. Well, that is partially true. What do we have here? We have v to the first power, v to the first power, v to the first power, and v to the first power. So everything is already first degree. However, you look for commonality among your constants, or common factors among your constants. Is there a number that divides 1? The number in front of v is a 1. 1 and 7? Well, yes, the number 1, but we don't factor out 1. So we just write this as v minus 7. There is no factoring that can be done on the first degree binomial v minus 7. So leave this alone. However, does something divide the constant 2 and 12? Yes. So you're going to be pulling from all of the different types of factoring we've looked at. What divides 2 and 12? Hopefully you say, well, even though this is first degree, you can still factor out a constant. So we're going to factor out a 2. Divide everything by 2. Since we took the 2 out, 2 divided by 2 is 1. We have a 1v. 12 divided by 2 is what? 6. So you're left with a 2 times quantity v plus 6. Now, multiplied by, what divides, notice, same thing. First degree, we look for commonality, or we look for numbers, factors that divide both, what am I saying? Factors of our constants, common factors of our constants. So what divides 10 and 60? Biggest number. Hopefully you say 10. Okay, so we're going to factor out a 10. 10 divided by 10 is 1, so we have 1v. 60 divided by 10 is 6. And now factor out here. What divides 3 and 21? Hopefully you say 3. Factor out a 3. 3 divided by 3 is 1, so we have a 1v. 21 divided by 3 is 7, so we have a minus 7. Now notice, what do you have on the board? You have successfully created products. Notice, does the v cancel with the v? Absolutely not, because the addition locks up both terms left and right. However, now that we've created products, look, what is to the left and to the right of the entire unit, v plus 6? Hopefully you say there's multiplication to the left and to the right of the whole unit, v plus 6. What about the 2? Yes, there's multiplication to the left and right of the 2. Is there multiplication to the left and right of the binomial v minus 7? Yes. Is there multiplication to the left and right of the binomial v plus 6? Yes. Now my question is, do we cancel top with top? No. We cancel top with bottom. Notice, 3x over x squared. We cancel what? Top with what? Bottom. So x with x squared, leaving an x. We cancel numerator with denominator. So you're looking at, also my question is, can we cancel across multiplication? If I give you 3 over 16 multiplied by 1 over 3, do the 3's cancel across the multiplication? Yes. So we can cancel across multiplication as long as we're canceling top with bottom. So notice, we can cancel the entire unit v minus 7 with v minus 7 because there's multiplication to the left and right of the entire unit v minus 7. We can cancel v plus 6 with v plus 6 because it's on top and on the bottom. We can cancel because there's multiplication either side of the unit. Can we cancel the 2 with the 10? Yes, divide them each by 2. 2 divided by 2 is 1. We don't write it. 10 divided by 2 is 5. So our final answer is just 5 over, since there's nothing left. Oh, I'm sorry, here's a 3. I'm sorry, final answer is what? 5 over 3. So our final answer is 5/3. All right, so that's just like homework question number 1. Homework question number 2, example. So the question is, does the P cancel with the P? No. In this problem, because of the addition. If we want things to cancel, what do we have to create? We have to create multiplication by factoring. So the faster you can factor, the faster your homework goes. So remember, everything that you guys do in this class from now on is based on factoring. We're looking at now example x plus 7 over 7x plus 35 multiplied by x squared minus 3x minus 40 divided by x minus 8. And I said in this class we factor everything down to first degree. Question, is this x to the first power? Yes. Is this x to the first power? Yes. Is this x to the first power? Yes. But what do we have here? We have second degree. Remember that second degree has to factor into what? Second degree will have to factor into 2 first degree binomials. Now, so we're looking at first x plus 7. This is first degree. We look for commonality or common factors among our constants. Is there something that divides 1 and 7? Well, we already talked about this. That's just 1. We don't factor anything out here. We don't factor out a 1 because we would just get the same thing. So x plus 7. What divides? Here we have first degree, but we have something that divides 7 and 35. What is that number? Hopefully you say 7. We can factor out a 7. Divide them each by 7. 7 divided by 7 is 1, so we get what? A 1x. 35 divided by 7 is what? 5. Okay, now multiplied by, here we have second degree. This is going to factor into what? 2 first degree binomials. What's going to give x squared? X to the first, x to the first. Now read it from the right to the left. We're looking for factors of what? Factors of 40 that subtract to make a 3. What are they? 1 times 40, 2 times 20, 3 does not work, 4 times 10, 5 times 8, 6 does not work, 7 does not work, 8 times 5, we see the repeat. We're looking for factors of 40 that what? Subtract to make a 3. What factors of 40 subtract to make 3? Hopefully you say 5 and 8. We put the 5 and the 8. Does it matter where we put the numbers? No. What matters is where we put our signs. Now, remember, the larger number matches the center. What is our center? Our center is negative. So which number gets the negative? Hopefully you say the larger number, 8, gets the negative, the 5 gets the positive, over. On the bottom we have first degree. Is there anything common among 1 and 8? No, other than the factor 1. So we leave it alone. X minus 8. Now, notice, in the original problem, the x did not cancel with the x. Why? Because the addition locked up everything to the left and right. However, in our result after factoring, notice, we have multiplication to the left and right of the unit x plus 5. We have multiplication to the left and right of the unit x plus 5. And we have multiplication between. So we can cancel top with bottom, and we can cancel the unit x plus 5 with the unit x plus 5. Why? Because there is multiplication either side of that unit. Now, question, is there multiplication either side of the unit x minus 8? Yes. So we can cancel unit x minus 8 with unit x minus 8. And what is our final answer? Hopefully you say, what's left? Well, we have a binomial x plus 7. And what's left on the bottom? We just have a monomial 7. So our final answer is x plus 7 over 7, and we are almost done. One more example. So this example is just like question number 2. The key to making your homework easy, or I should say the key to your homework, is the ability to factor quickly. The faster you can factor, the easier your homework becomes. All right, last question. Okay, so this one involves, notice we have a second degree on the bottom, but something is missing. Let's see what's going on here. So a question that's very similar to this. This involves a little bit more thinking, I guess. Let's see, x squared minus 10x plus 25 over 10x minus 100 multiplied by x squared minus 10x over 45x minus 9x squared. Now, notice we have multiplication between. This will allow us to cancel across from fraction to fraction. Now, we have second degree here. Okay, remember this will factor into 2 first degrees, so we read right to left. Two first-degree binomials. What are the factors? We're reading factors of 25 that what? Add to make 10. 1 times 25, 5 times 5. What factors of 25 add to make 10? Hopefully you say that's 5 and 5. So we put x times x makes x squared. We put a 5 and a 5. Remember, if we're adding, the signs are not different. The signs are the same. Okay, so the signs are the same. We look at our center. Are these both positive or both negative? Hopefully you say because the center is negative, both of these are what? Negative. Now, on the bottom, question, what degree do we have? Well, we have first degree. So if we have first degree, we can't factor the x down anymore. We're just looking for common factors among our constants. So what divides our constants here? 10 and 100. Hopefully you say the largest number is what? 10. So we're going to factor out a 10. And what's left? Well, 10 divided by 10 is 1, so we have a 1x. 100 divided by 10 is 10, so we have minus 10. Multiplied by, now, up here, notice, if I write x squared, x, and x to the 0, notice the first, we had our x squared term, our second degree, we had our first degree, and we had our x to the 0 term. So we had all three terms in the problem. We read from right to left and factor it, but what's missing here? Here we have what? Second degree, first degree, what's missing? We're missing our constant on the end. We're missing our number. So if this number is missing, if this constant number is missing, the problem actually becomes very easy. Notice, is x common to all three? No, because we have a constant on the end that does not have an x. But notice, if the constant is missing, do we automatically have a common x? Yes, so we're going to factor out that common x. If we take an x out of two x's, how many x's are left? Just one. If we take an x out of the 10x, we're left with just what? Minus 10. So if that constant is missing, you can always factor out a common x. Down here, notice we have second degree, we have first degree. What's missing? The constant is missing. So what is automatically common? The x is common, so we can factor out an x. Remember, we have one x and two x's. The maximum number of x's that we can take is 1. So we're going to factor out an x. What else divides 45 and 9? Hopefully you say 9. So we're going to take out a 9x, and what's left? So 45 divided by 9 is 5. We took out the x, so we're just left with a 5. Now, we had 9x squared. 9 divided by 9 is 1, so we have a negative 1. We took out an x, so we just have an x. Now, have we successfully factored and created products? Yes. Now my question is, okay, there's multiplication either side of the x minus 10. Does the x minus 10 cancel with the x minus 10? Yes. Okay? But looking at this binomial 5 minus x, does 5 minus x cancel with x minus 5? No. Pay attention very closely here. Notice, this is a positive 5. This is what? A negative 5. This is a negative x, and this is a positive x. Now, we've already talked about this concept in class a little bit. Okay, so what do we do if both signs are opposite? I want you to notice, positive 5, negative 5. Negative x, positive x. If both signs are opposite, you can get them to cancel. And how do we get them to cancel? We have to factor out an additional negative. Remember, if I write binomial x plus 3, can we always factor out a negative 1? Yes, we can factor out a negative, and what happens to the signs? The positive x becomes negative x, and the positive 3 becomes negative 3. Both signs change if you factor out a negative. So what we're going to do, now which one looks weird? Does the x minus 5 look weird, or does the 5 minus x look weird? Hopefully you say the 5 minus x, because we're used to the variable term being written first. So let's go ahead and let's take the negative out of the one that looks weird. Okay, so we're going to take the negative out of this one. If we take the negative out, both signs will change, and these will then match. So we're going to factor out an additional negative. I want you to put a negative in front of that 9. That means that you're factoring out an additional negative, and now change your sign. So the 5 becomes negative 5, and the negative x becomes positive x. Now check your signs. We have a negative 5, positive x. Yes, they match. So we're going to cancel the x minus 5 with the negative 5 plus x. What else? Okay, so we're done with the binomial units. Now we're looking at monomials. Does anything cancel on top with the 10? No. We're looking at our monomials, the negative 9x. Does anything in negative 9x cancel with what's on top? Yes. Notice there's multiplication x to this x and multiplication either side of this x, so we can cancel the x's. And our final answer is we have a binomial x minus 5 on top, and be careful on the bottom, you have two monomials. You have to multiply these together. 10 times negative 9 gives negative 90. And let's go ahead and just end the video here, and I will talk about more detail when you guys get back to class. Good luck on your homework.